In the next example, you're drawing cards with the letters from the word mathematics. Okay, we're going to find the following probabilities. In question number 1, this is with replacement, but this is a simple probability because we're only doing one thing. What's the probability that we would get the letter M? Okay, so we have to look at the letters in the word mathematics, all right, and we count them all up. And if you count them up carefully, you'll see that there are 11 letters in the word, and 2 of them are M. So the probability of getting the letter M is going to be 2 out of 11. Okay, in question 2, we want to get both M's in a row when we draw those cards. Okay, so to get the probability of M the first time, okay, well that's going to be a 2 out of 11 probability. But remember, this is with replacement. So after I draw the first card, I'm going to put it back in. So instead of having only one M, both of them are still in play, making it 2 out of 11 for the second card as well. I multiply these together, and that's going to give me a compound probability of 4 out of 121, and that is in simplest form. Okay, so again, if you replace it, you put the card back. All right, with the next 2 examples, though, these are going to be without replacement. So in the first example, I want the letter H, and then I want the letter S. So let's start with the probability of getting the letter H. Okay, looking at the word mathematics, there's only one of them, so it's going to be a 1 out of 11 probability. Okay, and I'm not replacing that first card, so when I reach in to get the letter S, now there's only 10 left, and there's only one S in the word mathematics. I multiply those together, and that's going to give me a probability of 1 out of 110. Okay, again, I want 2 M's in a row this time without replacement. So if I get a letter M the first time, that's going to be a 2 out of 11 probability. Okay, I'm not replacing the first M, so now there's only one letter M left out of 10 cards now. And so if I do 2 elevenths times 1/10, that's going to give me 2 out of 110. And that can simplify down. 2 and 10 have a common factor of 2. 2 becomes a 1, 10 becomes a 5. So this is going to become 1 out of 55 in simplest form. With the next set of problems, marbles are picked at random from a jar of black and white marbles. There are 4 white marbles and 10 black marbles. The marbles are drawn without replacement, so this is going to be a dependent event, okay? So in the first example, I want a white marble and then a black marble. So I know that there are 4 white and 10 black. That's a total of 14 marbles. So to get the white marble first, that's going to be a probability of 4 out of 14. Okay, since this is without replacement, when I draw my next marble, there's only 13 marbles left in the jar. Okay, 10 of them are still black, so it's going to be 10 out of 13 to draw a black marble. And now I'll multiply these together, and that's going to give me a probability of 40 out of 182. Okay, but again, I can simplify here. 4 and 14 have a common factor of 2, so the 4 can become a 2, the 14 can become a 7. All right, and now when I multiply those together, 2 times 10 is 20, 7 times 13 is 91, and there's our probability in simplest form. If I want a black marble first and then a white marble, okay, to get a black marble, it's a 10 out of 14 probability. To get a white marble the second time, there's 4 white marbles, but only 13 left in the jar because I didn't put the first one back. And again, this is going to give me a probability of 40 out of 182. And as we said with the last example, that's going to simplify down to 20 out of 91. Okay, 10 and 14 have a common factor of 2. That would become a 5. That would become a 7. And that's how we get 20 out of 91. Number 3, if I want a black marble and then another black marble, well, again, to get a black marble the first time, the probability is 10 out of 14. To get a black marble the second time, since I didn't replace the first one, now there's only 9 left out of 13 still in the jar. Multiplying here, that's going to give me a probability of 90 out of 182. And again, I can simplify. 10 and 14 have a common factor of 2. That would become a 5 and a 7. And then that's going to make my compound probability simplified as 45 out of 91. If I want a white marble and then another white marble, to get a white marble the first time, it's going to be a 4 out of 14 probability. To get a white marble the second time, because I took one out, now it's going to be 3 out of 13. I multiply those together and I get 12 out of 182. 4 and 14 have a common factor of 2. That would become a 2 and a 7. So that's going to simplify our probability down to 6 out of 91. Okay. In the fifth example, we want a white marble, a black marble, and then another white marble. Okay, so to get a white marble the first time, that's going to be a 4 out of 14 probability. To get a black marble, that's going to be a 10 out of 13 probability because we didn't replace the first marble. And now to get a marble that's white on the third try, remember we took one out already the first time, so now there's only 3 left. And there's only 12 marbles left in the jar because we've taken out 2 already. All right, we can go ahead and multiply all of those together, and that's going to give me 120 out of 2,184. Okay, but again, we can do a lot of simplifying here. 3 and 12 have a common factor of 3, so that would become a 1 and a 4. Okay, this 4 and this 4 can simplify down to 1s, each of them. Okay, and the 10 and the 4 have a common factor of 2. So the 10 can become a 5, the 14 can become a 7. And so now when I simplify, 1 times 5 times 1 is 5. Okay, and then I'm going to have 7 times 13 times 1, which is 91. And so we have a simplified probability of 5 out of 91. In the last set, we're told that in a game there are 15 yes cards and there are 5 no cards. The cards are shuffled together and placed face down on a table. The first player draws a card and replaces it before the second player draws. Complete to find the probability that the cards are drawn in that order. Okay, so we're replacing the first card, so this is going to be independent probability because we're going to have the same number of cards each time. All right, in number 6, we're doing a simple probability. We just want to know what's the probability of drawing a yes card. Well, they told us there's 15 yes and 5 no. That's a total of 20 cards, and 15 of them are yes cards, so it's going to be 15 out of 20, which you can simplify down to 3/4. Okay, for a no card in question 7, again, this is just a simple probability. We're only drawing one card. That's going to be a 5 out of 20 probability, which we can simplify down to 1/4. Okay, in question 8, this is where we get into the compound probability because we're going to draw more than one card. A yes card followed by a no card. Well, to get a yes card, we said the probability was 15 out of 20. And since we replace it, to get a no card, the probability is going to be 5 out of 20. There's still going to be 20 cards. We multiply those together, and that's going to become 75 out of 400. But we can simplify as we saw before. Up above in number 6, 15/20 is the same as 3/4. And in number 7, we said 5/20 is the same as 1/4. So that's going to make our simplified probability 3 out of 16. In number 9, we want a no card and then another no card. So again, we said to get a no card the first time is 5 out of 20. And since we replaced that no card, to get it again, a second no card, it's also going to be 5 out of 20. So this is going to make our probability 25 out of 400. But again, we can simplify both 5/20 simplified down to a 4th. 1/4 times 1/4 is 1/16 when we simplify that probability. In question 10, we want a yes card followed by another yes card. To get a yes card the first time, it's going to be 15 out of 20. We replace it, so to get another yes card, it's also 15 out of 20. And that's going to make our probability 225 out of 400. But again, we said before that we can simplify the 15/20 down to 3/4, so that's 3/4, and that's 3/4. 3/4 times 3/4. Simplified, we're going to have 9/16 as our compound probability. Okay, in the last example, they tell us a third player jumps in. So now we're going to draw 3 cards in a row. We want it to be a yes, and then another yes card. Well, to get a yes card the first time, it's 15 out of 20. We replace that card, so to get another yes card, it's 15 out of 20. And again, we're going to replace that card, so to get a third yes card, it's 15 out of 20. Multiplying all of those together, that's going to give us a probability of 3,375 out of 8,000. But one more time, we can simplify all of these 15/20ths down to 3/4. So that's a 3/4, that's a 3/4. Okay, so for our simplified probability, numerator 3 times 3 is 9 times 3 is 27. Denominator 4 times 4 is 16. 16 times 4 is 64. And so our simplified compound probability would be 27/64.